and welcome to another episode of Maths in an Empty Classroom with me, Mr. Sutton. This is the first video in the lesson on friction, and I'm just going to be explaining a little bit about how friction works, going through an example where friction has different values. Right, so first thing we need to talk about is the coefficient of friction, which we label with the Greek letter mu. Now, the coefficient of friction is a numerical value for how much roughness there is between two surfaces. So it can take a numerical value from 0, which means there's no friction, up to 1. And the greater the value of mu, the more friction there is, so the rougher the contact would be between the object and the surface. The other thing that we use is this formula for the maximum value of friction, sometimes known as limiting friction, and that is equal to mu, the coefficient of friction, multiplied by the reaction force, normal reaction force R. So what we're going to look at here is we're going to look at one example where we have a force T acting horizontally on a box, and we're going to look at what happens in different scenarios where the value of T is different. So we have a block of mass 8 kilograms in contact with a rough surface. Now, rough is the key word here because that implies that there's going to be friction, and we have to think about that in our calculations. It's being pulled along horizontally by a force T newtons, where the coefficient of friction between the block and the surface is 1/5. So I'm just going to go over here and write that mu, the coefficient of friction, is equal to 1/5. Now, I'm just going to label some of the forces that are acting on this system. Now, we have the weight going downwards, which is going to be 8g, mass multiplied by gravity. And we have a normal reaction force that the floor is exerting on the block. We have this force of tension here, and then we have this force here, which we're going to label with a lowercase f, small f, for friction. Now, the first thing that I'm going to do is I'm going to use this equation here to find the maximum value of friction. So F max is equal to mu multiplied by R. Now I know that mu is 1/5 because I've been given that as part of the question. And because there are only two forces acting in the vertical plane here, and there's nothing going on that's going to be lifting the box or pushing the box down, I know that the normal reaction force in this case is going to be equal to the weight, which is 8g. So what I can do is I can do 1/5 multiplied by 8g. Now remember, in maths g is 9.8, and I can get a numerical value for the maximum friction, which comes out as 15.68 newtons. Now that's the maximum value that friction can take. Now let's just consider this first scenario where the tension is equal to 10 newtons. Now in this situation the block will not move because the tension force pulling the block is not sufficient to to overcome friction. It's not enough to overcome that. Now the value of friction in this case is not 15.68, it's actually 10. Because friction will only resist as much as it needs to stop movement up to the maximum that it can exert. So that's the scenario here. So in part A, what happens when T is equal to 10 newtons? The box does not move. Now what I've got is the same diagram drawn under here because we're going to do part B. The only thing that's changed here in part B is that the tension is now 15.68 newtons. Now remember, we calculated that the maximum that friction can be is 15.68 newtons. So in this case, the magnitude of friction would be 15.68 newtons. Now that is the maximum that friction can be. Now at this point, the box is still in equilibrium, but we say that it is on the point of moving, because if this tension force goes up by any amount at all, it will overcome the force of friction and the box will start to move. So here we have equilibrium, and the box is on the point of moving. Third scenario, part C, again I've got another diagram for this, is that now T is 20 newtons. Now if T was 20 newtons, friction would be taking its maximum value, which would be 15.68 newtons. So friction resists motion up to its maximum value, but then once the force being applied overcomes that friction maintains this value throughout the subsequent motion. And what we could now do is we could use a resultant force equation. So we could say that the resultant force is equal to mass times acceleration, and we could use that to work out the acceleration of the particle. So the resultant force is going to be equal to 20 minus 15.68, and that's equal to the mass, which is 8, multiplied by the acceleration. So the resultant force is 4.32 newtons, is equal to 8a. And if I divide that, I'm pretty sure that's 0.54, I'm just going to check. Yeah, 0.54. So in this scenario, when the tension force is 20 newtons, the box begins to move with an acceleration of 0.54. So there we go, that's how friction works and how it behaves. Join me in the next video where we'll look at finding acceleration for different particles. I'll see you then.